Industrial automation programming goes beyond just PLCs. It also includes professional HMI panels like this one from Deep Sea Electronics. In this video, I will show you how to program this type of panel using the Codesys environment. These panels aren't limited to factory use, such as managing production lines or conveyor systems. They are also perfectly suited for mobile machinery. For example, the panel you see here can be installed in a fire truck to control key operation. That's exactly the application I will use to demonstrate the programming process. These HMI panels are commonly used in industries like mining, where they are installed in excavators or stackers. You will even find them on luxury yachts. And the best part, you can program everything in the familiar Codesys platform, from logic to complete visualizations. Check this out. The panel features 16 fully programmable buttons that you can link to your custom-built interface. It's built from high-quality materials and offers robust communication options with vehicles and other electrical automation systems. You can even connect it to the internet. If this sounds interesting to you, and it should, make sure to give this video a thumbs up and subscribe to the channel for more content on industrial automation and robotics. Let's dive into programming the Deep Sea Electronics HMI panel for mobile machinery applications.
Now I will show you how to operate a sample visualization in Codesys designed for a mobile machine, in this case a fire truck. So let's move on to the main screen, which is the cockpit. Here, as you can see, we can monitor the basic parameters of the vehicle, just like in any other vehicle. We monitor similar parameters, such as speed, and we can monitor the speed on an elegant dial gauge in kilometers per hour. I also have the number displayed with a decimal point, so you can easily monitor these parameters, extract them properly from the vehicle, and visualize them. Let's move on. Next screen. Here we have several things, but here we can already control, for example, the lighting. The first icon is the light pole, and here we can control the lighting sections. Look, we have physical buttons mounted for our panel from Deep Sea Electronics. And if I hold this button, first of all, notice that we can change the backlighting of the buttons. You can do this programmatically in Codesys. Meanwhile, this is how we turn on individual sections in our lighting system. We can also do this using the icons on the visualization. The system is mounted on a boom, so we can also adjust its height using the buttons on the display. And importantly, the operator can perform their work here while wearing gloves. Let's move on to ladder control. And here we can perform several operations. Let's start with the ones at the top. As you can see, we can rotate the ladder around its own axis, and we can do this using the buttons on the visualization or the physical buttons. Next, we can change the angle of inclination of the ladder. At this moment in the simulation, we can simulate the number of firefighters currently on the ladder. And depending on the number of firefighters, the zone to which the ladder can be extended, the maximum zone, is marked with this light blue area. You see, if I decrease the number of firefighters, this zone expands. Let's assume we want to have 3 firefighters, and I extend the ladder beyond the zone. Then an alarm about exceeding the safe zone is displayed. The next screen is the mix of water and chemicals, probably intended here for firefighting. So here we have several icons, and we can, for example, adjust the ratio of this mixture accordingly. At the moment, we have a mixture ratio of around 80%. We can also do this using buttons, or alternatively connect physical buttons. Let's move on to the last screen, which is the Diagnostics screen. Here we monitor several parameters, such as wind speed in kilometers per hour. Next, we have atmospheric pressure, external humidity, and temperature. We also have this elegant chart where we can view certain parameters in real time. In this case, we have, let's say, a simulation of the power unit and its utilization in percentage. And that's all. Let's go back to the service screen, where, for example, you can change the language. At the moment, we're operating in English, but if you switch to German, then on all screens, let's go back and change the view, the language will switch to German. And as you can see, here we have alarms, descriptions, and visualizations in German. You can simply create a universal visualization like this and add the appropriate language for your client.
Curious how to get started with programming HMI panels for industrial use and building powerful process visualizations? These days is easier than ever. We've created a step-by-step online course that walks you through programming in Codesys using structured text language. If you're ready to start working with HMI panels and launch your career in industrial automation, check out the link below to join our course. You'll get access to exercises, project templates, and ongoing support through our platform, contribute.tech, where we help each other learn and grow every day. Start programming these powerful panels and become part of our growing community. This link is right below the video.
Now I'll show you what a finished program for such an HMI panel looks like, which is written in Codesys. In such an environment, you can also create this type of visualization and upload it to HMI panels. So let's get started. Of course, at the beginning, you need to select the appropriate device you're working with. Here you have the entire project tree of your application. I'll show you which devices are currently available if I click on Update Device. Here I can select devices that are in my device portfolio. And there are also devices from Deep Sea Electronics. I'm using the M812 panel, which is a panel that has 16 built-in buttons, but we can also choose smaller panels with fewer buttons and simply choose the one that meets the requirements of our application. I'm choosing the M812 and starting the work. Below the device, you'll find the application tree and certain settings. The entire program is created in the application tree. We have the alarm mechanism and the visualization. However, at the beginning, I'd like to take a closer look at the device settings. First, we have the device settings tab. And here, among others, in the device settings I/O mapping tab, we can find the backlighting of our buttons, and we can use this register to light up the buttons. Here I added a tool called cross-reference list, and I can check where in the program this address is used. Well, this address is used to change the backlighting of these buttons. If I click on it, I'll be taken here, and look, I have the options green and red, meaning green and red backlighting when the button is pressed. And depending on which button is pressed, that's the color shown here. We can even preview the backlighting here. It really works as it should. So you see, I can refer to these addresses and use these buttons in the program. Now, the next setting is, of course, the button settings. And here, look, we have these 16 buttons that are present on the visualization, and we can use them accordingly in our program. And look, here we have the input address. Of course, it's an I address. It's the bit for the first button, the second, and so on. This is located in the I/O mapping tab, and I can do the same. For example, copy this address and enter it into the cross-reference list, paste it, search for it, and here I also have it used in the program. In this case, or even here, we have the button, which changes the height position of the lighting system. And in this section, we turn the lighting on or off. Okay, so now you know how to use these buttons and how to use their addresses. So let's see what's happening in the program, and we'll start from the top of the application. Here, at the beginning, we have alarms, and alarms are used to display certain alarm states or warnings on the visualization. We have several alarm classes, such as warnings or serious errors. We can simply acknowledge them, and then we need to eliminate the cause of the alarm. Okay, if we go to the alarm groups, then as you can see, we have several different conditions here for these alarms, and they have assigned appropriate classes and corresponding messages displayed on the panel. If you want to know more about alarms, of course you'll find more on our blog, on our YouTube channel, and in our courses. It's worth learning so you know how to use this in your visualizations. Next, we have the handling of the mobile machine itself, and here all functionalities, for example the cockpit. So we have a function block, and within the function block there are appropriate methods that handle everything. Let's take a look. Inside the method we have various program flows such as indicators, warnings, in essence the entire cockpit handling. Here for example we have a section with icons for oil. Maybe I'll show it on the panel. This is the cockpit. Here we have icons for oil, battery, and also a fuel level indicator in the tank. So all of this can be handled and programmed here. Then we have several structures and also enumerations that we use. However, as you can see, there are also interfaces. This is a topic related to object-oriented programming. Next, we have visualization design, where we design individual visualization screens, even the elements that we use throughout the entire project. So let's move on to the individual visualizations. Here we have the cockpit, ladder positioning, service status, language change, as well as the mixer and lighting control. So all these screens are added here and can later be used in the main web visualization. Or in the HMI, for example, if we don't have physical buttons, we can also use something like this to visualize the buttons. Alright, we also have the recipe manager, and when it comes to the declaration of buttons, you can see here the global variables, and at each address the physical buttons are declared, plus the backlighting of these buttons on the appropriate register double word. Okay, so now we'll log into our controller. I'm connected via Ethernet here, so I click Scan Network and it found M812. I'm connected. The program is compiling here and should be uploaded to the controller shortly. The program is running, and importantly, we can now preview individual windows within Codesys. I have the visualization here, which we can control from the panel level, so let's check. I'm now controlling from the panel level. We've moved to the cockpit. And I can view the same in Codesys, so this way we can test our visualization and check whether everything is working correctly. Okay, that's all when it comes to testing. Of course, as you can see, the possibilities are truly vast. They're unlimited. Everything depends on your imagination and on the project you're going to carry out. So I invite you to think about what kind of applications you want to create. So leave a thumbs up below the video and, of course, a comment. Do you see an application for Deep Sea Electronics panels in your automation projects? Codesys is a great tool that continues to evolve, constantly changing, and offers many programming options not only in factories, but also, as you can see, in mobile machines.
Now we know how to begin programming HMI panels in Codesys, and it's absolutely worth it. Codesys continues to evolve and is quickly becoming the future of industrial automation. After testing this HMI panel myself, I was impressed by its build quality. Deep Sea Electronics has equipped it with a powerful processor, and the buttons are extremely well crafted. and this is definitely a device I will be using in upcoming Control Byte projects. Thanks for watching, and don't forget to like and subscribe if you want more content on industrial automation, hardware and programming. Remember, automation isn't just for factories, it's also transforming mobile machinery and even luxury yachts. It's a great place to start your career. Of course, our YouTube channel. See you in the next video.